Bismillahirrahmanirrahim. So this is now the second part of the first lecture. I've divided the lecture in two parts because to reduce the size of the total video. The video was too lengthy, so I thought to reduce and divide it into two. So let's get started where we left off. We have studied till now, till present session layer, and from now on we are going towards transport layer. In transport layer, basically I've told you that transport layer is basically a bridge between the host entity and the network side. So it is responsible for source to destination delivery for the entire message. It also ensures that the whole message arrives at the destination intact. Means that it ensures the reliability of the network. Any network, the important factor, there is an important factor called reliability in any network. So that reliability is ensured by transport layer. Now, what are the functions of a transport layer? The first function is termed as service point addressing. It basically gets the port address to deliver the message at the right port. For example, if you are using multiple programs at the same time on a same system, so it is very desirable to deliver the message at the same application there it belongs. So for that reason, service is known as service point addressing, and it is also termed as port address. It means that the by the desired port or the application. The other function of transport layer is it basically segments and reassemble the packet. As you know that the size of packet matters a lot. If you are transferring a data or any message basically, and the message size is too high, so it is not possible, and it is not recommended. Even it is possible, then it is not recommended to transfer the message into in a single file. Same is the reason that I am trying to divide the lecture in two parts, because if one of the packets get lost, the whole entire message will be corrupted or lost. So to reduce the amount or chances of or probability of corruption and losses, it is highly recommended to divide your message into small segments, and at the receiving end, divided message is also reassembled. So the division of a message is known as segmentation, and after reception, the combination or reassembly is done at the receiving end. This is all done by transport layer. Also, the other function which is very important of transport layer is flow control. You see, if you are communicating with a server, and the speed of the server is, let's say, 100 mbps, sorry, and your device cannot handle more than 10 mbps. So basically this is the transport layer which tells the server to slow down their processing speed as per your demand. The server can transmit up to 100 mbps, but your device cannot be able to handle that effectively. So this transport layer will send the information to the network and to reduce the speed from 100 to 10 mbps or any value. Other important functions, as we have already discussed, that transport layer is basically the bridge. So it has to ensure the reliability, so it will be working with both of the ends. So to make it a good and reliable communication, the function is known as connection control. The communication between a transmitter and the receiver can be done in two ways. One is connectionless, and another one is connection oriented. Connectionless mean that the transmitter do not have to establish or dedicate a fixed path towards the receiver. And in connection oriented mean that the transmitter have to dedicate a specific path towards the receiver for all the communication. So you see that all the communication in connection oriented will be go through the same path, and in connectionless service, it is also possible that one packet goes from one route, and the another packet goes from another route. So this is the difference between connectionless and connection oriented. UDP is basically connectionless. This is known as user data graph protocol, and it is faster than TCP because it do not wait to find the basic route path towards the receiver, it simply transmits the packet. So it is faster than TCP, that is transmission control protocol, that is connection oriented. In TCP, we have to wait for a path to establish, or a connection, or a channel to establish, or a route to find out, which will be seeing in the coming slides, that how a route can be found out. For services like online gaming and live streaming, where you need fast streaming or fast speed, you go for UDP. And for important emails and where such applications where the reliability of a data is must, for that reasons we go for TCP. Now coming towards the next layer, that is network layer. So network layer is responsible for source to destination delivery. Network layers also ensures that the packets get from its point of origin to its final destination, that means transmitter and the receiver. These terms are basically denoting the transmitter and the receiver. So a network layer oversees the source to destination delivery of entire packet, but it does not the difference between this and transport layer is that it does not recognize any relationship between those packets. For example, let's say all the packets are same for this network layer, so it does not discriminate or differentiate between these packets. uh, but this network layer, I have also told you that is important and responsible for source to destination delivery. That is the reason it treats every and each and every packet independently, so it does not it does not have any idea about the relationship or dependency between the packets. Now, what are the important functions of network layer? The first very important function of a network layer is logical addressing, means IP allocation. You already know about IP in data communication, so no need to go in depth in that. We will look over IP addressing in the coming lectures. Function of network addressing is basically routing. And what is routing? It is basically a method to move a packet from source to destination, and it is based on IP allocation, that is logical addressing. So now it includes the routers that are interconnected in inter-networking devices. So here comes the part of hardware that I've told you in the previous part of the lecture, that in the last three layers mostly there are combination of software and hardware. So here comes the router, which is a hardware device. Basically routing is finding the path from the transmitter to the receiver. And we will be studying several protocols in the coming lectures. The some major or famous protocols are OSPF, that is open shortest path first, and BGP, that is border gateway protocol. After that there comes a data link layer. So data link layer is responsible for node to node delivery. It receives the packet from the network layer and creates frames rather than segments, which were generated by transport layer and given to the network layer. And these frames actually basically are so data link layer is responsible for node to node delivery. It receives the data from a network layer and creates frames. Then it adds physical address to these frames and pass it to the physical layer. You see the diagram is showing the same process that I have mentioned above that. What are the main functions of data link layer? The first main function of data link layer is framing. It means it divides a bit of streams into small frames that are easy to handle, that are easy to manage. Similarly, the other function that is very important is known as error control. I hope you have already studied error control, error detection, error correction. So that is why I will not go in depth, but there are several protocols like parity checks, checksum, CRC. You can ensure the correctness of the message or the bits. The most important protocol, the most important function of data link layer is access control. Basically, data link layer is divided into two subgroups. One is LLC, that is logical link layer, and the other one is MAC, that is medium access control. And this medium access control, I hope you have studied about slotted aloha, pure aloha, and different techniques, scheduling, polling, token ring, and the most commonly used is basically CSMA and CSMA slash CD slash CA, collision detection and collision avoidance. So these all are basically there to ensure that there is no collision among the devices which share a medium. For that reason, we are using access control in data link layer. The first layer, here comes the first layer of OSI model, that is physical layer. This layer is basically responsible for the transmission of data towards the receiver. It basically deals with the mechanical and electrical specifications of the transmitter, medium, and interface. Now, what is transmitting medium and interface? Interfaces are basically the connection or links between different entities in an OSI model, and transmission medium is basically a channel that is that is established from the channel to the receiver, from the transmitter to the receiver, and it can be either wired or it can be either wireless. The main functions of physical layer involves, as I told you, that it is basically the last layer, or you can say the first layer, and it is directly connected to the media. So the responsibility also incorporates the properties of media or interface between the transmitter and transmitting device and the medium. So it basically reduces the it acts as a bridge between the OSI model and transmission media, and it also represents the bits in the encoded, so it can be secured. You see that we will use different modulation techniques. You have studied, I hope you have studied different modulation techniques and line coding techniques, in which I just want to tell you that basically in analog system we use modulation, and for digital system we use line coding technique. So in both of these cases, bits need to be get to in shape of a signal. For that reason, we have to represent the bits in terms of signal, either analog or digital. And for that purpose, this physical layer uses modulator or line coding techniques, etc. It also physically also manages the data rate and transmission rate. And data rate, you mean number of bits per second, and the baud rate. If you are using an analog system, you might have heard about baud rate. So baud rate is number of signals per second, and bit rate it is number of bits in that signal, basically. And so it is also ensured and managed by the physical layer. Now, what is synchronization of bits? Synchronization of bits mean to make the receiver and the transmitter clocks at the same time, to encourage them to be synchronized. It is the reason because of that is to reduce the amount of error between the transmitter and the receiver packets. So it is also done by physical layer. The other parameters are line configuration, physical topology, transmission mode. Either the user want to go with half duplex, or he want to go with full duplex. So it's also ensured by a physical layer. Here is a summary of all the OSI model, starting from the application layer, where the network allow access to the user to its resources. Then it is presentation layer. Presentation layer basically translate, compress, and encrypt the data. Then comes the session layer. A session layer establish and manage and terminate different sessions. Transport layer provides a reliable end-to-end message delivery and error recovery. Network layer basically move packets from source to destination, providing them a path, and known as routing. And data link layer then organize the bits into frames and provide node to node delivery. And the last or the first layer of the OSI model, that is physical layer, it manages mostly about the channel or transmission media. In reality, there no data are directly transferred from one layer to another layer into the machine. Instead, each layer process and control the information to the layer immediately below it. You see, no, there I've given an example, host A and host B. If host A want to transmit to host B, it is not directly it cannot directly communicate with the host B. So it will follow all the OSI model layers, and it will pass the data to the physical layers till the end, and the physical layer will be responsible to transmit the data towards the user through a channel or a transmission medium, and from that physical layer the data will be traveled back towards the application layer. I have told you earlier that OSI model is not practically implemented, but it is a base, or you can say a background, or a base. It provides the base to any other models that will be followed. So TCP/IP model is basically a practically implemented model. It is widely used nowadays in internets, and this layer, this TCP/IP model, you see in the diagram that it also corresponds to the OSI model. I'm just want to show you that the TCP/IP model consists of, you see here, 5 layers: application layer, transport layer, IP layer, data link layer, and physical layer. So the first 3 layers are combined into the single layer in TCP model, that is application layer. The transport model is kept as itself, and the last 3 layers were also kept at itself. So today we learned about ISO OSI reference model in depth, and also we have studied about TCP/IP model. In the coming lectures, we will look about other topics related to OSI model, known as collision domain and broadcast domain, etc. Which thank you very much. Allah Hafiz.